Okay. So, last lecture, normally I have this lecture, I do a review session, and I do a review lecture where I go. The review session I hold is optional, but I would say almost everyone attends or watches the video lecture that I prepare. So what I'm going to do is I'm going to just post the recorded review session from the past. I'll probably do the springs. Yeah, I'll have to do the springs. It's really important because I contextualize everything is the way I would explain it. So I try to summarize okay, we've done all these different types of algorithms, but let's look at the 5 different types we've really done that are just applied a couple different ways. And then I show common not really common mistakes, but common misunderstandings that I see throughout the semester. I go over those. And I do a bunch of examples of writing things in 2 ways, one in the vector form and one in the loop form. You'll see in the reviews, in the practice exam, you'll see some of that. So let me just review linear algebra and I'll talk a little bit more about the exam. I also won't be able, I normally have a session where I can review our topic today, which I won't, so I'll just post that on D2L, this slide on that. So the main thing for linear algebra is understanding the difference between doing the regular asterisks and the dot asterisks. So regular multiplication and matrix multiplication, both what those are the syntax difference between the two, but what they do. And I will be asking you questions on the final exam that test that you actually understand when the dot is needed and when it is not. So you cannot just guess or just put it in there like we do sometimes when we're programming. So I'm going to test that you actually understand that difference. For this topic, we went from converting a system of linear equations into its matrix form. I saw in your pre-labs that I think everyone was able to rewrite the coefficients into the A matrix and the unknowns into the B matrix. I did have something on the pre-lab that talked about augmented form, which just places the 2 next to each other in the same matrix, which is just something I wanted you to be aware of because it's in a lot of the linear algebra help. And then being able to solve systems of equations the various intrinsic ways. I hope this is really useful for you just in your classwork to just solve systems of equations quickly. Typically you'll have 3 or 4 equations and unknowns and homework sets and stuff, and this would be a really quick way to solve those. And then to talk more about kind of the numerical techniques and the algorithm associated with linear algebra, we went into Gauss-Seidel's algorithm. Remember, Gauss-Seidel is an iterative method, so it does not directly solve for each unknown. So that means that sometimes it will not converge. So you should have seen in the lab that you were able to get the first 2 systems to converge with the iterative method with a guess of 0, but the 8x8 on the back page does not converge. And that's because that matrix is a very sparse matrix with lots of zeros, and it's not well suited for a guess and check method because there's very few of those coefficients that are non-zero. So the guess doesn't change very much from one iteration to the other. So the Gauss-Seidel algorithm, and you'll see this in the review, the algorithm itself is a repeat loop from the bigger side. It has a sum inside of it, and it has an error checker around it. And those are some 3 of the algorithms that we wrote in this class and other of our labs as well. So normally at the end of the semester I go over the statistics of the class. I usually highlight 100% attendance and scores on the quizzes and stuff like that, but obviously can't do any of that with 8 people, otherwise it would be really obvious who I was talking about. But what I'll talk about is just a little bit of what to expect on the final exam. So the first thing, and this is all in the practice exam on the front page. So for yours, it's a little bit different. It's written correctly on yours, but that you can use 2 crib sheets, 2 8.5 by 11 crib sheets, front and back, and you can put whatever you want on that. And then a pencil. So that's all you can have with you at the exam. And then I just wanted to talk a little bit about how you can prepare for the exam. So the main way that you should prepare is to go through every pre-lab and lab that you've done, and anything that you don't think you'd be able to remember or that you would need to refer back to, you write down on your crib sheet in an organized way that you can easily retrieve information from it. As well as going through the overview of topics, which is posted on D2L with all of the labs and pre-labs. And same thing, I put a lot of syntax on there as well that you can copy down. So for the most part, I'm not just having you retrieve syntax, that's not usually what I'm looking for on the exam. So it's not just a matter of writing down the syntax as much as it is making sure you understand it so that you could apply it in a question. Let's see. One thing that's very different about the final versus the midterm is that we've done these topics that are applications. So derivatives and integrals and what we're doing today. What was the first one we did? What's the other topic that we did? We didn't do statistical analysis, interpolation, etc. So those all have with it formulas. These formulas don't have anything to do with the algorithm necessarily, but they're things that you would need if you were, for example, going to apply it by hand or something. So you need to make sure you have all that. I'm not giving you any of that information. So if I say apply the linear interpolation formula, you should be able to do that with whatever you need to be able to do that. So make sure you have all those written down. And then the last thing is I post those summaries after each session of the thing I just did, where I review like the most important or the things you should learn from this topic, and then I would go through those as well as all the debugging questions and those tips and tricks. And just kind of reviewing all of that and moving anything onto your crib sheet that would help you is usually enough. When you start looking at the labs, which is what I have here on this first step, it is rarely going to help you to just copy down the entire algorithm of the lab. I see people doing that. I would say most people do that. They just write down all the code or print off all the code and tape it to their sheet or whatever. I rarely see people actually using that. It's more important that you understand those because you have to write similar algorithms but different. So it's up to you, but the idea of this reviewing your lab and stuff is that you really think about understanding the algorithm, writing down what you wouldn't remember, and that kind of thing. So the practice test is posted, and I want to just point out a couple things. First, it is not a full-length exam. It is just sample questions from each type of question that I'm gonna ask. None of these questions are going to be on the exam, and there's not even going to be a similar question with just something slightly changed. These are just to get you an idea of the style, but for example, if I put a theory question, what do I have as my theory question? So the theory question is an interpolation question. I will not put an interpolation question on the final exam. That doesn't make sense for that theory. I'm not going to give you that same question but with different numbers. That's not how the exam works. So this is the format. It's just like the midterm except for the theory section is added. So I'll show you what an example of that is. Short answer, are those more straightforward questions where I'm just asking you mostly syntax questions, but they're straightforward syntax questions that you should just know because you've used that kind of syntax all the time. Couple debug questions, a couple read code questions, and then the difference also in the final exam is the write code is going to be much heavy. It's going to be much heavier for you guys because you took your midterm exam very early in the semester relative to what's normal. So you hadn't even done functions yet when you took the midterm exam. So your write code section is going to be weighted much heavier than your, I think your midterm was 30%. Two very straightforward questions. These are going to be much more significant. And I'm really looking for you to show me your algorithm development skills. So given a problem that uses pieces of algorithms that we've already written, like filters and repeat loops, sums, like all those really typical algorithms that have been in most of the labs, I want you to be able to pull those out and be able to piece them together. And that's not to scare you, it's just your guys' midterm exam was much more straightforward than normal because of the way that the summer class is working. And I could tell that by grading it. It's normally, the distribution was very unusual. I think the lowest grade was really high. So the final exam is going to be much more typical for this class. Okay, so short answer, I think these are pretty straightforward. We didn't do statistics, I think last semester either. But anyway, so I wouldn't ask this exact question, but it's like this type of a question, which is like what prints to the screen when the following command is executed. So it's usually some sort of like calculation, logic type thing. Or the question could be conceptual short answer. So like, you know, if you're trying to achieve this, like you're trying to understand this about this type of problem, what statistical technique would you use? So it's like asking you to conceptually understand the types of things that we did. You guys have any questions about that one? Okay, here's an example of these theory questions. So normally during the semester, every lecture we do these as clicker questions. So that's one thing that's very different about this summer section. So I'm going to keep that in mind when I write these. But the idea here is if you have the following data, this is kind of like your x, this is your y. What would be the linear interpolated value for a star equals 1? So being able to go through that algorithm by hand and find what b star is. Any questions about that? This is from the practice exam. And then, so for the rest of the sections, I think it's pretty clear what these sections are, but there's a couple differences. And you'll see this in the review as well. So throughout the semester, we've just been kind of like sometimes using a vectorized form, sometimes using a loop form, sometimes distinguishing them, or maybe some of you have gotten into the habit or been more comfortable with one, but can like read the other or something. So one thing that the exam will include is measuring your understanding of going between them. So I'm not going to be asking you to vectorize like super complicated algorithms or anything like that. But if you go back to when we first introduced loops, you should be able to define vectors using the vectorized or the loop form. You should be able to do calculations with the vectorized or the loop form. You should be able to do logic using logical indexing versus a loop. All of those things will be tested. So they're on the practice exam, and I go over a lot more of them in the review. I have a whole section where I go over like 5 examples of the difference between the two, so you can follow along and do that. The review is really long, so keep that in mind.